Okay. Okay, I think we can start. So, just a reminder, what we decide is to take this hackathon offline, and we, in every few days, we will put another task and another step in the tasks. You have all the tasks here, but you can follow and see if you did exactly, as we did or differently. And we will have a chat and we have ideas and we can continue with that. So good progress on everyone, that because we started late, so we don't have enough time to finalize everything. And it's very important for us to go to the more interesting thing, because the first thing is the workshop and technical, how to work with FCP, and we learned. Here we want to learn how to do advanced FCPs. And then we have an hackathon of ideas that you can do it in groups or in a single, and prepare some presentation of your idea, what we can do with FCP. And this hackathon is for today with prizes, and we have good big prizes in this hackathon, as we mentioned. So let's start. So first of all, there are three steps. Okay. First of all, we will see the part of building with the code of building the FCP. Then we will see the visual builder that we have and how we can use it as a developers, not as a traders. And also you can use it as a trader, of course, but how to use it as a developer. And then we will learn about advanced FCP, what FCP is capable of that we didn't spoke about, which is pretty advanced stuff that you can use in your hackathon ideas. So you can use it to think whatever you can do with the FCP. So let's start here with the code. So we spoke about the FCP engine. This is the part that knows to get an FCP and knows to transcode it to EVM code and to run it. So in the code, I might just make it a little bit bigger. Okay. So in the code, we have currently this batch multi-sig call engine. This engine is the most advanced engine that we have. Why we have many different engines in FCP? Because sometimes we want FCP, which is pretty simple, but very efficient on gas. So we can have an engine that doesn't know to do anything, just to send tokens, for example. But we can have this like Swiss knife engine that knows to do a lot of stuff. Okay, and this is what we are focusing today. So I'm making an instance of this FCP batch multisig. Then I'm setting some options, and then I'm adding like calls to the FCP. I have two ways to add calls. One way is the native way. You see, this looks like an ABI. You set what is the solidity type, what is the value, what is the name, and in this way you define the interface. To remind you, every call is a call to a smart contract, which is part of the FCP. So you need to say, okay, what is the method that I'm calling? What is the name of the method? And then what is the fields in this method? Just you do in ABI. So this is the first one, this is the second one. This is like a standard transfer. So ERC20 transfer, the method is transfer. The first one is the recipient, type of address. The second one is amount, type of UINT 265. So we set everything here. And this FCP creates a new call in the FCP. The other way is to use plugins, which is much easier. In this ERC20 transfer, it's not so different, but in more complex protocols, it makes life much easier. So instead of putting it like this, the ABI way, You do it like the TypeScript way. You are saying, okay, I want to plug in ERC20. I want to have a transfer. It all have type inside. So you have to put the recipient. You have to put the amount. And so everything is validated and is easy to use. So this is the second way to make calls. Flow control. Now, as we mentioned, we can add a lot of calls in the FCT, but FCT has another thing that we didn't spoke about, is that I can say in the FCT that, okay, try to do this work, but if it fails, do something else. If it succeeds, do something else. So I can do like if then. Now, in order to do the if then in this language, we have again two ways. One way is to do it natively. So to do it natively, we have a flow option inside each call that's saying what to do with that call. For example, you can see this, okay, continue, fail, revert. It means that this is the default behavior of any call inside Solidity. If this call succeeds to this contract and did not revert, continue to the next one. Otherwise, revert all the transactions. But we have many different types of flow control. So we can say, okay, please continue if it succeeds, but if it fails, also continue. So I don't care if this functionality or this call succeed or reverted, do not revert all my transactions. So this can be useful if you want to send, for example, to many persons, you want to send the same salary or something like that. So you want to do a multi-send, but it might be that one of them will fail. You don't want to fail all the multi-send. So you can say, okay, even if it fails, I will deal with this later. Even if it fails, continue to the next one. We have also the ability to say if it fails, stop. Meaning that, okay, I'm trying things. And now if it fails in this 3 call, 4th call, 6th call, don't revert everything, just stop here, but accept all the changes that were to the blockchain till now. So we have a lot of flexibility. This flow, along with the jumps, is giving us the power to do also blocks, if then with blocks. What does it mean? I can say that if, as I said in the first one, if it's success, continue. I can say what means continue. Continue can means jump over some boxes. So I can say, for example, okay, continue, fail, continue. But if it fails, the jump will be 2, meaning that if it succeeds, it will do the next call. If it fails, it will jump about, over the two next calls. So this way I made like a block of if. Now, it's not so easy to work with this like this. This is a low level working. So we have also a builder that makes it like this. Very easy to write with. So we do fct.start with. So start with, and then get my Kirobo balance. Then check if it's greater than 1,000. Then send it to both. Otherwise, so if it fails, then send all the Kiro to Alice. What does it mean if it fails? If is greater fails. What does it mean is greater fails? It means it wasn't greater. So in this way, I can build like a developer-friendly code that I can build like very complex flows to be used in the FCT. So FCT is not just putting a lot of calls together, it's just also doing flow control of them. Now, in order to make it simpler than that, even more simpler, we have the visual builder. So this is our visual builder. In our visual builder, we see on the left side the plugins that can be used. Every plugin here is a call. Every box is a call. Every box is a call. we see the fields that we can set in the call, and we can connect calls, as you can see here. We can connect on fail or on success. If on fail, if on success is not connected like this, if I will now take this one, let's disconnect both of them. Okay. So now, if this succeed, it won't go to the next call because on success is not connected. If on success is not connected, the default behavior is to stop. If on fail is not connected, the default behavior is to revert everything. So now if I will take this and connect this here, so now if this succeeds, it will go to the next one. Now I can put another one. Let's take a token transfer, for example. And I can now put the on fail on the token transfer. So I can say something like that. Try to change this token to a different token. Check if the value is greater than what we plan to do. If it's not, send this token to another place, back to my wallet or to another wallet, so on and so forth. As you can see, we have inputs and we have also outputs here. So every transaction, every call inside the Solidity might have also outputs, might be return types. And these return types can be connected and be input types of another calls. So for example, here I'm doing a swap. I can take the amount out of the swap and I connect it to the amount in of the greater than checker. So if I connect it, you can see that now the amount in is actually the amount out of the swap. And I can connect it everywhere. So I can connect it even now. I connect it to here. I can connect it now to here also. So I'm not limited in that. So I can have a very complex, let's remove that, a very complex flow with variables, which are return types from different calls. And you know what I did here, actually? I did a limit order with these two boxes alone. What I did, I'm swapping a token, and I'm saying, check if the output is greater than this number. If it's not, it will automatically revert because I didn't connect this to anything. When I try to connect, you see that this one is great because you cannot connect backwards because, as I explained, there is no loops in FCTL. So it's very straightforward and simple, and you can see exactly what you are doing. Now, let's publish that and see how it looks in the MetaMask when I sign. So when I press here, I'm now publishing it. And you can see in the MetaMask that I'm signing exactly of what I saw in the UI. So I see the name, I can see the limits, valid from, expired at, I see the max gas price that we'll speak about soon. I see the first transaction, the first call. In the first call, I can see what is the flow control, continue on success, revert on fail. I can see what I'm calling. I'm calling a swap with no slippage protection. I don't need slippage protection because I have the validator afterward that checks that is greater than the number that I want. I can see that this is the amount. This is the method. I can see that this is the values inside the method. And I can see also the greater than. So I can see I'm calling the greater than. I see this is the amount number 1. This is the amount number 2. And we need to explain this is like a magic numbers to represent this FD, for example. It represents a variable, return variable from a different transaction. So FD is like future data that comes from a different call. And number 1 meaning the call number 1. So this is like the raw data. This is what you sign. But of course, inside FCT, use the builder, inside SDK, use the builder, so it's very easy to use. Okay, now I'm signing this, and then it goes to the blockchain, and now it's I have it here part of my this limit order waiting to be called. Now I can use this for prototyping. Instead of starting to write things, I can just prototype here. And we have a new feature this week, which is called custom plugin. Asaf will show it at 6 o'clock after we'll do the hackathon. What does it do? I can put here the address of the contract, any contract. I can put the ABI of the contract, and the system will generate this kind of plugins, like I have here in NFT, like I have here in Uniswap, in Aave. It will generate this automatically. Now, I have 3 different types of calls. I have call, which is an action, changing something on the blockchain. I have a call to check a value, which is like a static call in Solidity. And I have also library calls, which are like delegate calls. So I have all the types of calls. Delegate call, for example, I have here in Uniswap, for example. So I have here a library call. Where is it? Sorry. Okay, I don't have it here. Anyway, we have also library calls and also static calls. Okay, any questions so far regarding what we spoke? Okay. Now, let's go briefly, before we start the ideas hackathon, let's go briefly what FCT can do. Because we saw only tip of the iceberg, so I will go fast about things that FCT can do. And then you can take these things and use it in the ideas hackathon to find things to do with FCT, interesting things. So this is the documentation of the platform, which means the documentation of the contracts. And I will go briefly on the important stuff, on the new things that we didn't spoke about yet, that the FCT can do. Okay. So, first of all, we spoke about the idea of versioning, but I have to say that you can do a strict versioning, meaning that if we bring a new version of a new engine, your FCT will still run on the old version. So when we do a new version, we don't replace the version. We add a new version. And if you decided that your FCT runs on version 1.1.1, he will still run on 1.1.1, so we can be sure that it's future-proof. We can be sure that in the future, it will be running we cannot change it, or we cannot change the way that it will be running. Okay. Second thing is the limits. So we spoke about the valid from expired at. Let's speak about max gas price limit. Gas price limit meaning that we can say, okay, I want this FCT to run, but it will be in the future. I don't know how much gas it will take. So I'm setting the max gas price, but it's not the actual gas price. Max gas price meaning I'm not willing to pay more than that. This is the max that I'm willing to pay. But the activator is motivated to reduce the price as much as possible, because then he earns more money. And I won't go to it now. Why is that? We can go this offline, or just read here the white paper that explains that with calculations, with the mathematics of the activator's actuator contract. And here is calculation that explains that if the activator saves the user money and uses a lower gas limit or gas price in the actual transaction, he will get more money. Think about it like this, that I was willing to pay, let's say, $500 for this transaction because it's important to me and I gave a high gas. If the activator succeed to lower this to, let's say, crazy, to $10, so we saved money from the miner of $490. So this money is split between the user and the activator. So both of them win. So it's a win-win. Okay, so recurrency. So as we talked about before, we can have recurrency in FCTs. So we can run the same FCT many times. Multi-sig, we can have external signers. The external signers can be more than one. We can have a different way of minimum approvals. I will explain what I mean. We can say, for example, and I have an example here in this green one that says, okay, I can do like this. Do a multi-sig of minimum 2 signers, but the signers are address 1, address 1, address 2, address 3. So what I did here is that address 1 can sign by himself because he has 2 instances, but address 2 cannot and address 3 cannot. They need to join again together in order to approve that. So it can be in a company that the manager can immediately sign the FCT and approve it, but the workers need to have 2 of them approving the FCT. So we can do this also. Computed is a way to do math calculations. So we can do sophisticated math calculations, and this is the formula in general. So you can do almost any math that you can do in Solidity. You have like power, you have like a multiple, division, subtraction, everything. Next, we have the payment system. So think about that now we are making an FCT, okay? Let's say we are making a peer-to-peer transfer. And think about that we want that the initiate side will pay for the whole FCT. Not that I will pay for my part and the other will pay for his part. We want that the initiator will pay for the whole transaction. So we can do that. In every call, the pair index saying who is the pair of this call. So I can say that for call 1, the pair is call 1, for call 2, the pair is call 2, but I can say that for one the pair is call 1, for call 1, the pair is for call 1, for 2, the pair is also pair for call 1. So now I can make some interesting payment plan that I can say, okay, I can have FCT with 3 parties, but only 2 of them will pay. And they will split on the payment of the third one. In order to make a split payment, you just put 0 in the pair index, then it's split the payment of this call is split to the others. We talked about the call types. And we have permissions. Permissions meaning that is again good for companies. Permissions meaning that we can set, okay, this FCT can be run only by who has this and that permission. And permission system is open. It's like a 16-bit that can be just numbers. And we can say, okay, this wallet and that wallet has permission, although they don't belong to my vault, but I give them the permission. Now they can run my FCTs, but only FCTs that I signed with this permission bit. So only FCTs with this permission bit they can run. We spoke about the flow control. So let's continue here. Okay, variables. We have the ability to put external variables. What does it mean, external variables? Think about that I want to do now peer-to-peer swap, okay? But I don't know with whom. So how I will do a swap now with someone that I don't know who is the other side. I don't know what is the address. So I can say like this, okay, send my NFT to address X. This is the first call. The second call, address X will send me 1 Ether. Now address X is variable, but it's totally safe. And now I made like a marketplace that I can say, okay, whoever wants to trade with me, just sign and you will become the X. So variables are external variables are also supported. Also globals, by the way, I know inside the FCT, what is the actual gas price, what is the miner address, what is the activator address. I can give money to the activator directly, I can give money to the miner directly. And let's speak about this founder address, and let's speak about flash loans. Currently, what is the problem with flash loans? The problem with flash loans is that it's very technical, very complex, and you have to have a bot that will do that. You have to give him like your private keys, and it's pretty risky and pretty complicated for the average user to use it. So how it works in FCT? In FCT, there is like a virtual founder, and this is his address, which is like a magic number address. And you can put in this FCT that this address will send me X tokens. And what happens behind the scenes? The activator will initiate a flash loan that will give you these X tokens from the flash loan that's written inside the FCT. Otherwise, the FCT cannot be run. So now I can use flash loan without actually all the technical stuff. I'm just saying I need this money to do that, and I will return this with this interest. Otherwise, it will fail, it won't work. And that's it. So me as a user, I don't need to think about it. I don't need to do all the technical stuff. I don't need to give my private key to a bot. I'm just saying what I want to do. That's it. Another important thing to know about flash loan. About FCT. Let's say we did here a swap, okay? And after the swap, we did another swap, and then we did another swap. Okay, so I have a swap, I set another swap, make it smaller. So think about that I did a bigger. Think about that I did a swap, and then another swap. I'm not putting any inputs now, just to have a point here, to explain a point here. Okay. Think about now that these swaps are like starting from Kiro, swapping to, let's say, USDC, or to another token, and then swapping to WETH. So I have a lot of swaps. How can I manage the slippage and all the problems that I have on the way? I have a lot of dangers. One, front running. Second, sandwich board. Slippage that can be happening. So in FCT, I don't care. I'm just going to the end, taking like a validator, greater equal, connected it, and connected the final result, and saying the final result should be greater than this number. Now, I don't care what happens here, because it can be a huge complex logic with many boxes, with many conditions, with many swaps. It can be with loans, with many things. But I can check in the end, and I can have multiple validators, that I will get what I expect. Otherwise, this FCT cannot be run. And this also changed the way that we build things, because for the user, he can check only this validator in the end, and he can be for sure know that this is safe for him, never mind what complex logic we have inside. Okay, so this was also very, very important to mention. Okay, so far, any questions regarding FCT and the things we can do? Okay. Just going back here for a second. Okay. So We have also support that I didn't mention in ENS. And FCT also supports storage and secure storage of two types. And I will explain. You can have a storage that exists only when the FCT is running. So you have a storage that can be updated only from the FCT, within the FCT. It's a different contract that implements that detects that FCT is running, and it keeps all the storage of this FCT secured that cannot be changed with another way. It can be run only if FCT is running. It can be activated, changed. It can be read anytime, but write only on FCT run, and only in the slots that belongs to this FCT. So this way, I can have now FCT that is connected to another FCT. Because I can do FCT that has many conditions, but if some conditions are met, it will write something in the storage. And I can have now two different FCTs that check the storage, and one will do this thing, and the other will do another thing according to the storage. So now I can do like between FCTs logic. So this opens up the things that we have in Solidity, of course, state variables that you can keep. So here you can keep also arrays, you can keep any variable that you want inside this contract, and you can retrieve it on different FCTs or write it or change it in this FCT. And what is nice that if this FCT has a recurrency, runs many times, you can change this many times. So you can write how many times I run, you can write on each one what happened, you can do a lot of stuff like this. So it opens up a lot of possibilities. Another thing that FCT works with contracts, right? So every contract can be like part of the FCT. Meaning, if we spoke about the storage is a contract that is external to the FCT, but it's actually a contract that implements a runner. Because it's implementing a runner, it can do things only within an FCT, but this runner is not an on-chain wallet, it's a storage mechanism. Also flash loan, it's a runner, but this runner is a flash loan mechanism. So we can extend this FCT with many runners that can do many different stuff. And they become part of the FCT system because they can now only activate within an FCT and not outside an FCT. So we can extend the FCT as much as we want with many functionalities. For example, the new one that we talked about to add, there is oracles, but there is also a thing that in Solidity or in blockchain in general, you don't have dates. So if you want to do every 30 days, it's every 30 days. But if I want every one of the month, it's harder to do. So we can build a contract, again, that will be a runner that will help us to do just that. And now we can add it to the system, extend the system. And now if there is an FCT that uses this contract, he will be able to set a validation that this is the first of the month. So now I can say, okay, do recurrency every 31 days, but I have a validation that is only the first of the month. So now I protect myself and now it's the first of the month. Okay, any questions so far? Okay, do you start to have an ideas to do something with things with FCT? I suppose to be. There are a lot of things that can be done here. I know. It's a bit overwhelming, the things that we can do, but think about it. It's like a new language. It's like a new Solidity, but you are writing things off chain. So I want to emphasize another thing that will help you to think about ideas. Think about that in modern days today, when we make a software, when we make some kind of application to the user, we are used to do rapid updates, very fast. Blockchain is very slow. Development on the blockchain is slower, much slower, because let's say, I will give you a simple example. Let's take a 1 inch. 1 inch, they have a nice limit order. Nice. But now they think about, it would be nicer if I can do a limit order with this or that, what I spoke before. So in order to do that, they need to have now a new contract. Go to the audit, go integration with the server, doing all of this stuff, changing the UI, setting the users now to use the new contracts, all of this stuff in order to do this small change. And if you say, what is the problem? I will do this in advance. So your contract is not secure because now it's fully upgradable. You can change it whatever you want. So it's not secure. So here you gain also security, but also the ability to move very fast. And because the user sees what is signed, the contract itself can do like a static analysis and can help the user. Because currently, if I will do, and I want to show you this, I'm going to, if you didn't know that or didn't notice that, so let's take an example, Uniswap, but it's in almost all the protocols, doesn't matter. I will choose now some Uniswap. I want to change with Kirobo. Let's put the number. Let's do the other way around, so I don't need to approve anything. Okay. Need to approve. Let's change maybe what network I am. Well, okay, let's see. Maybe here it will be. Okay, so I will approve. Just a second. Let's go here. I have more money. Approve. Let's do the approval. Very fast. Now you see that in the approval, this is a signature, right? So because this is like a standard thing, sending token, approval of token, MetaMask can show us what it does. But for protocols and things that are not standard, every protocol is its own contracts with its own way, you don't get this. So if I will do swap now, okay, so I have here data, execute, bytes, and uint. And let's see what are here the inputs. Oh, very interesting. So I have to say that in the office I showed them, I did the hack on MetaMask. It's not so hard to do. It's very frightened. It's not hard to do. That you do a swap, Uniswap shows you that you do the swap, but actually the money is sent to my wallet. So it's possible. So you cannot count the UI. So you count the UI, you see this thing in Ledger, it says like blind signing. So you blind sign, and that's it. And you don't need to hack now the private key. There's a lot of projects that protects the private key, but you don't need. You just fool the user saying doing A and it does B. And as we saw in FCT, when we published and ran this, and I have it here already, I changed the, sorry, just a second, approve that. Cancel, check. I don't want to approve that. Okay, so here I did this limit order. So when I published it, you saw, and so I published it. Let's do like this. Let's do like this. I published it. So you saw here exactly all the details of what I'm doing. So if, for example, I will take here, for example, the publish. So if the tool won't be the address that I expect, or if any other field won't be the field that I expect, so I can reject it. Not all the fields are easy to read 100%, depending on this MetaMask, because here, for example, it doesn't show valid from as dates, but as numbers of seconds. But still, it's something that I can check quite easily. That don't happen in Uniswap or other protocols that they have this X thing that I don't know what to do with. So this is also very important to say. Now, about our builder, it's open for you, by the way. You can play with it. I want to speak about payments because we didn't talk about that, and this is also important in FCT. Okay. So in order to run FCT, you need to pay for it. Now, it's not a free transaction, right? By the way, there is a way to do a free transaction. You can put as payer index 0, so you don't want to pay, and you can send money directly to the activator. So this is also possible. So it's also possible to give your users the ability to use the system without payment, or embedded payment to the activator, or subscription of some kind, and then the activator will pay for the transaction. So this is also a possibility in the FCT. Okay. So if we are speaking about what I want to speak about here is the fuel. We call it here power or fuel. So think about that I'm doing a transaction. Now a small fee I want to give to the activator. Now think about that sending the money will cost more than the money that he earns. So it's problematic. And it's important for us to make the activators as miners, because then they don't care about the content of the transaction. It's not that if this transaction is profitable, they will run it. If it's not, they like the miners. They just see, okay, what is the max gas price? How much I will earn? I will run this type of transaction. So to reduce the payment from the miners, each activator puts a stake inside the actuator contract. And this actuator contract gives him the ability to activate at a higher level of earning. What does it mean? It works like proof of stake, but a special one. What does it mean? It means that it works like this. I'm an activator. Let's say in a simple example, I'm an activator and I put 50% of the staking is mine as an activator. Now, when I'm activating an FCT, I earn X money for this transaction, the fee. Now, if I will run another one in the same block, I will earn 0. So what will happen? I will recover to my full profit depending on the slice or the part of my money inside the pool. So if I am 50% of the pool, it will take 2 blocks for me to recover. So I can activate an FCT. Next block I don't want to activate because it will be half of the profit. One after that, I can now activate again because it's full profit. So this makes a way to a proof of stake like that if you stake more, you have more activations, more earning, but without blocking. We don't block the say, no, you can activate. No, everyone can activate, but you want to earn money for activations. So put more shares inside this activation pool. And in this activation pool, money does not move. It's just writing this kind of movement from these users to these activators in this activation. So the users need also to put money inside. We call it fuel. It's like you have gas and Ethereum, so this is fuel. And this fuel is taken automatically in a way just listing in the contract. And you can redraw it anytime you want. And this aggregates activation, aggregate movement of money, and makes the running of FCTs much cheaper and much more reasonable. Again, you can bypass all of that if you can put for your user 0 inside the payments, and you handle a different way of payments. Then you take all the payment of the transaction as an activator, and then you can make it's like a VPN inside this system, because no other activator will activate because it doesn't earn any money. So if you put inside your FCT sending or signing something that sent only to your wallet some profit and not to other wallets, so no activator will activate. You will be the only activator for these FCTs, because nobody will earn, only you will earn from them. So you can do this also in your FCTs. What? Yeah, not very profitable. Okay. Okay, so I think I'm done with explaining, showing and let's recap. We spoke about, we spoke about, let's go from here, doesn't matter. We spoke about the building, that we can build a transaction, an FCT in code. We saw how to build calls with plugins, without plugins. We saw that we can use the builder to build the flow more easily. We also saw the visual builder that helps us to make, and we'll see here later on, very sophisticated DeFi stuff that was done with this builder, because we have these custom plugins that we can put whatever we want. So many different protocols, new protocols that just came up. And this is also an important thing. For business to succeed, you have to move fast. There is a new hype, new thing. You want to get up and running with your application for this thing very fast, and not in a few months. So in FCT, you can do it in a week. If we have like a working example of different application that you did, it's very easy to change it and very fast to have a new solution, totally different, with NFTs, with peer-to-peer, with payments, with whatever you want to do. Okay, so let's take here now a break, and let's go to the Ideas Hackathon. Let's take 5 minutes break, okay? And I will explain what we need to do in this hackathon. The Idea Hackathon, it's with very interesting prizes. We have, first of all, we will have a special NFT that we'll get. And this NFT will allow you to run FCTs on the mainnet for free amount of, so you can test the system, you can run your own transactions, and also money prizes. Okay, so 5 minutes break, and let's meet again. What? Yeah.
It's the second version. You have a different interface. Like hexagons that connect to each other.
You think about, yeah, we did some different experiment because this current model is, and you see it's 6 o'clock. It's you can do another stuff because like and you change the name, the title, and change the and then you save it with and in the next version you will be able to do like statements or the code like close up. So you can make an app that for the user it's only one but inside the and I didn't mention that we have in the way that you write your address inside the FTP, and you get an option that the remote interactivity. So in this system, people will be able to do the yeah, and then they will publish them with the rating system. Yeah, and then you can just drag it, put it, and use it. And
are really aware that you don't just the line to code, you'll be able to use it inside the algorithm. So think about the time you now next mini program. So I can give you the mini program, take this mini program, put it in point, and then connect it. So instead of seeing a lot of boxes, you now have one of the right now one box. The now there's a lot of more behind the result is now like
We're actually speaking like which are creating a comparison tools. Though we got very far in the utilization and so everyone has the idea is exactly the model that you mentioned. Is that the interface is exactly zero. You're using the actual the interface is very simple. And you connect to each other to it's a step. It's a step with then using them deployed and using. So one thing is that by having the background and your one is integration with a bit of fun with two parties, and this all creates a new ecosystem.
What we do level of it, we can do, we can have so we use this so
It's not a system.
it's not it's
Very scary.
you can think about it, yeah, because what is nice about, by the way, about the idea that think about we are the same company, we are the I'm telling you the money. So what we need to do the partner, another one can connect it with the partner. But we have to now do that and very good. The same one, the same partner will be the actual partner is that where you are. And there are three partners, our you and the other. Each one of the partners, not all so we and the seven can start, we can start, we can. I'm talking about yeah. But now we will complete because okay, so